Hello, ladies and gentlemen. This is going to be a video to show another way to solve equations, and this is going to be by a method called inspection. And I have to tell you, this is one of my favorite math concepts in all of grade 7 because if you can keep in mind that this is sort of like a puzzle, I find it one of the most engaging ways to do any of the math that we're doing. So what we're going to look at in this particular video is we're going to look at something that looks like this. So we've got a y minus 4 equals 6. We already talked briefly about before about how to solve these things by doing sort of test and check. But there's another way to do it, one way that doesn't involve any testing. And so I'd like to show you that way. And the idea, again, that we're looking for is we want to be figuring out what is y. We know y minus 4 equals 6. We have an equation. We have a result. What is y? So that's what we're going to look at. So two things we really want to keep in mind as we go ahead into this particular strategy are two ideas that you've already covered quite a bit, the idea of equations and the idea of zero principle. So first over here on this side, the idea of equations is to really remember what this equal sign means. This equal sign is an equality sign. It shows that what is on the left is the same as what is on the right. So when you say a equals 7, you understand that a in fact is 7. It's worth the same as 7. A equals 7. It can't equal anything else because the equal sign is there. Okay, you're going to get, ultimately your answers are going to look like this. That's going to be your final thing that you show me as an answer. So it's important that you recognize that you've gotten to the end and you've solved the question when it does this. Okay. The other thing I want you to look at is the zero principle over here. We talked about the zero principle when we were looking at integers, and the main thing we talked about is how a positive integer and a negative integer of the same value, when you add them together, they always equal 0. And that's going to be a strategy that you're going to use to help you for a lot of the different equations that you're looking at. You're going to be keeping in mind what the opposite integer is of the number that you're looking at. So keep both those things in mind as we move forward. So I wanted to start by looking at a super easy one that you guys know just by looking at it. So let's take a look. A plus 4 equals 6. You guys know without doing any math that a must be 2, because you know mathematically that 2 plus 4 equals 6. Basically, you're just filling in an empty spot. And some of them will literally be just this easy, and you're welcome to just substitute in when that's the case. But usually you have to prove how you got there. So that's part of what we're going to do. So what you want to do is we want to do what's called, delete that. We want to do what's called isolating the variable. So a is obviously the variable. We want to get it all by itself. So we want to wind up with an equation that says a equals, and there's going to be something there. There's nothing else on this side of the equal sign, just the variable. That's what we want to get to. So we want to take anything else that's on this side of the equal sign, and we want to get rid of it. Okay? So the easiest way to get rid of it, let's change that. The easiest way to get rid of it is to do some simple math to do that. Okay, so let's do a little math to do that. So let's say a plus 4 equals 6. This is a positive 4. Using the zero principle, what would I add to this to get rid of the positive 4 to make it equal 0? And hopefully you guys can keep in mind I would add a negative 4. Positive 4 and negative 4 sort of cross each other out. They equal 0. Okay, now what's important is that this equal sign means that whatever is on one side is the same. That means if I added a negative 4 over here, I must also add a negative 4 over here. So I subtracted 4 from a plus 4 to get rid of the plus 4. So I must subtract 4 from 6, the same side. That, if I take out all the junk, leaves me with a equals 6 minus 4. Okay, a equals 6 minus 4. So once again, what did I do? I just want to highlight it for you here. I added a negative 4 onto this side to get rid of the positive 4. I don't want to add a negative 3 or a negative 5 because I'm trying to get it down to 0. Okay, a plus 0 basically, which is just a, right? So I want to use the sort of opposite integer of what I'm looking at there. But to keep both sides equal, if I add the negative 4 here, then I also must add it over here because that's what the equal sign means, that both sides are the same. So that leaves me with a equals 6 take away 4, which is 2. Now you guys knew that already. We solved that before just by looking, but I wanted to use that to prove to you. Okay, so what you're left with is a equals 4. Now this is the final answer here. Okay, that's what you're going to give me. You're going to say, Mr. McPherson, I have figured out by inspection that A equals 2. Okay, so now we'll try a few different ones that you're going to see, and we'll go through them one at a time. You can try them ahead of me if you want by pausing, and then I'm going to solve them for you, okay? Okay, so C minus 17 equals 11. So what do I want to do? I want to eliminate this negative 17. It's minus 17, and the way to do that is by adding a positive 17. So by zero principle, it kind of crosses itself out, and that means that I have to add that positive 17 over here. Okay, so these guys kind of cross each other out, and what I'm left with is C equals 11 plus 17, and that ends up being C equals 28. Okay, C equals 28. So once again, it's really important to recognize that what I did was I added the positive integer to the negative integer, and they kind of cross each other out. They become 0. Okay, and so you take away 0, or C plus 0 is just going to be C. So on this one, it's important for you guys to remember what a lot of us have been forgetting, and that's when we see something that says 6r, what that actually means is 6 times r, right? So this is 6 multiplied by r gives us 42. So how are we going to solve this? Well, in this case, we can't really use integers to help us, but we have to do the opposite. So 6 times r, we want to divide that by 6, right? 6 over 6, right, which equals 1. That gives us 1r, and I'm going to divide this side by 6, and 42 divided by 6 equals 7. So r equals 42 divided by 6, which is 7. Okay, what did I do there? I divided 6 by 6. Okay, 6 divided by 6 is 1, and 1r is like 1 times r. And remember, 1 times any number is just that number, right? And 42 divided by 6 is 7, so r equals 7. So sometimes you're also going to see ones that have multiple numbers on the left-hand side. So here we have 7p, which is one operation, 7 times p, right? Whatever p is. And then we have a second one, plus 2. We have 2 operations on one side. So to isolate, we're going to get rid of one piece at a time. The piece we get rid of first is always the piece that's not attached to the variable. So in this case, the plus 2 is not attached in the same way that the 7p is. So our first step is going to be to, you guessed it, we're going to subtract 2. Okay, positive 2 and negative 2 equals 0, and that means over here we're going to subtract 2. That's going to leave us with something that looks like this. 7p equals 23 minus 2. And that means that 7p equals 21. So we're getting pretty close now. We're not quite there yet because we have an isolated p all by itself. This is another case where we're going to divide. 7 times p, so we're going to divide that. Okay, and I'm showing you the division in this sort of fractional way. 7 over 7 is the same as 7 divided by 7, which always equals 1. Okay, and that will give us the answer 1p. I want you guys to remember 1 times p equals p. And you can test that with any number, right? You know that. 1 times 2 is 2, 1 times 3 is 3, 1 times 4 is 4. And over here, that means I'm also going to divide this that way, or 21 divided by 7. And that's going to leave me with 1p, or just p, equals 21 divided by 7, which is 3. Okay, p equals 3. Similar type of question here, but now with some subtraction. So 9c minus 6. We're going to get rid of the minus 6 first by adding a plus 6. Okay, positive 6 and minus 6 equals 0. That means over here I'm also going to add plus 6. That's going to bring me to 9c equals 36. And this is where a good knowledge of your multiplication tables comes in hand, because hopefully you can do something like 36 divided by 9 in your head and know that that equals a number. But fair enough, let's just do it either way. 9c, we're going to divide that by 9. 9 divided by 9. And we're going to divide 36 by 9. 36 divided by 9. 9 divided by 9 equals 1, so that's great. That gets us our c all by itself, which is what we want. And 36 divided by 9 equals 4. 4 times 9 equals 36. I like to talk about fact families because we learned them when I was, when I was teaching back grade 4, grade 5 math. We talked a lot about fact families, and we would know, for example, that 9 times 4 is 36, and 4 times 9 is 36, and 36 divided by 9 equals 4, and 36 divided by 4 equals 9. That was sort of something you could memorize to sort of help you with the multiplication tables and help you know something. So if you know what multiplies to 36, you also know how to divide 36. So C would equal 4 because 36 divided by 9 is 4. This one might look a little strange because of how I've had to type it out, but basically this is m divided by 3. That's what that slash means. M divided by 3 equals 12. So it's m divided by 3 on this side equals 12. And it's the same sort of idea. We want to multiply by 3 to get the other answer because we want to know, we want to do the opposite, right? So whatever m is divided by 3, we want to multiply by 3. So I'm multiplying by 3 on this side, and I'm multiplying by 3 on this side. So what I'll end up with, we'll eliminate that 3 on the left-hand side. I'll end up with m equals 12 times 3. Okay, and that will equal, hopefully our multiplication table will tell us that will equal m equals 36. And that makes sense for our answer. M equals 36 is the correct answer. So here's a few samples, and I want you to, you're going to pause the video in a minute, and then I'm going to just pop the answers all in. So you want to try and solve them beforehand. So remember, your answers are all going to look like just the variable on the left-hand side equals one number. Okay, and that's going to be the answer to the whole thing. So just pause the video when I stop talking, and when you turn it back on, give it a second or two, and then all the answers will pop up, and then we'll talk about them a bit more. Now there's the different answers. Okay, R equals 10, U equals 20, V equals 57, R equals 80, P equals 8, and F equals 67. And one thing I haven't really talked about and that I absolutely love about these, and if you stuck around to the end, I'm glad, because you can solve these and know if you have the correct answer without ever having to get feedback from me. You'll just know. And the reason you'll know is because if you've done this correctly, you take your answer and you plug it back in. So let's look up here, for example. For R equals 40, if you find R equals 10, you can check your answer by simply doing 4 times R, which is 10. If your answer is 40, then you know you've gotten it correct. There is no other way. Okay, same down here. If you plug 20 in for the U, 3 times 20 is 60, plus 7 equals 67. You know for sure that you're correct. If you plug in 80 over here for the R, 80 divided by 4 equals 20. You're correct. You don't need me to give you that feedback. You can check for yourself just by looking back at your answer. And I really love that too. If you go on to the next slide, you'll see a kind of a fun little challenge for you.